Hi everyone. So in last video, we have seen the compiler directives. We saw the types of the compiler directive and we saw the overview of it. So in today's video, we are going to see the detailed explanation of timescale compiler directive. So let's start. So what is the timescale? So timescale compiler directive defines the time unit and time precision for the Verilog module. So here is the syntax of it. So we can define with tick timescale along with time unit and time precision. Example, take this example. So here, tick timescale, 1 nanosecond time unit along with 1 precision, 1 picosecond precision. So what does this mean? So this means that your simulation will treat #1 as a 1 nanosecond and your simulation resolution is accurate up to a 1 picosecond. So we'll see what is time unit and time precision. So the time unit tells the simulator how to interpret your delay values. So let's say you have entered #10. So what does it mean? So in general, you will see this as a #10 time unit. But if you define the time scale as a 1 nanosecond, I mean there you define like 1 nanosecond time unit. So it will consider that time unit as a 1 nanosecond. So here, if you define this 10 #10 means it will be considered as a 10 nanosecond and the time precision. So this defines how fine-grained your simulation time can be. It's the smallest unit of the time your simulator can understand. Let's understand this with a real-life example. A 100-meter race, a player A is finishing in 12.459 seconds and player B finishes in 12.452 seconds. Clearly, player B is winner. Now imagine the time recording device has a precision of just 100 milliseconds. That's like time scale of 1 second to 100 millisecond in Verilog. So both the player will be recorded at finishing in 12.4 second. But you can't determine the winner. Your measurement was not accurate enough. Now let's upgrade your stopwatch that has a 1 millisecond precision. That is 1 second to 1 millisecond. The times are recorded as player A's time is 12.459 second and player B has 12.452 second. So clearly here we can determine player B is the winner. So moral of the story is if your time precision is too coarse, your simulation might miss the important transitions, delays, or race condition. So we'll see one code example. So here I'm taking tick time scale as 1 nanosecond time unit with 1 picosecond precision. So module is defined in initial block. We have started writing the code with #5 with a display statement, #2.3 and #2.2. So what it will display? So first display statement will come at 5 nanosecond. Then second will be add up and will come at 7.3 nanosecond and final will be come at 7.5 nanosecond. So this will be possible because the precision has defined for 1 picosecond. Now I have a question for you. What happens if I use precision instead of 1 picosecond, I use 1 nanosecond precision? Please write down your answer in comment section. What if you don't use this time scale? What happens if you forget to add the time scale in the design? Uh, so if you don't specify the time scale, simulator usually assume a default value. So generally the default value will be 1 nanosecond to 1 nanosecond, but it's not guaranteed. It depends on the tool. It is not consistent across the tool. I hope you understand the concept of time scale. And if you like the video, please share it with your friends. Please press the bell icon and subscribe the YouTube channel. Thanks.